Good morning, this is Dr. Turner with Integrated Math 2. Today we're going to be talking about section 4.3, which is special cases for solving quadratics. We've actually already seen this in 4.1 and 4.2, where we were looking at special cases using difference of squares and also looking at perfect square trinomials. It is going to affect what we do in the following sections, so it's re-emphasized here. So it should be familiar, and hopefully this is a pretty quick, easy unit. Usually I try to do quite a few examples for you, but this one's going to be a little bit shorter because we've already seen these formulas. So your difference of squares, remember, is a squared minus b squared, and that is equal to a plus b times a minus b. So if you are doing factorization or solving by factoring, it's meant to be a shortcut. This does come into play in other types of mathematics and other sections that we'll talk about later in the year. But honestly, if you forgot how to do this, you could always do the x and solve the other way. But if you recognize these patterns, then it's very easy to crank this out. X squared minus 16 equals 0. And it's called a difference of squares because most of the examples you'll see with this are where your b is a perfect square. Your b squared is a perfect square. Remember, your perfect squares are when you multiply a number by itself. So 1, 4, 9, 16, 25, 36, 49, etc. If you have a multiplication table handy, and you could Google one, if you look down along the diagonal, it'll tell you all your perfect squares. I do recommend that those are memorized, and I would like to say that by this point, students have their multiplication tables memorized. Not all of you do, which is fine. So if you need to pull up that resource, I would say by Math 2, it's fair to be using multiples up to, let's say, 15 squared, 16 squared, but it can go all the way up to 20 and higher. So keep that in mind. So seeing this, 16 I recognize as a perfect square. So if I was trying to solve it, I could simply write it as x plus 4 times x minus 4, which means my solution, setting each of these equal to 0, is negative and positive 4. And you can write those separately, or you could just write it as a single answer, plus or minus 4. And you could keep going. X squared minus 25 equals 0. Well, x squared minus 25 equals 0. 25 is a perfect square. Square root of 25 is plus or minus 5, which means my solutions are negative 5 and positive 5. X squared minus 81 equals 0. 81 is a perfect square. So x plus 9 times x minus 9 equals 0, which means my answers are negative and positive 9. Now, if we were in person, these can get a lot more complex following the same pattern, but because we're just doing these online, these are the only ones I'm asking to be able to do. Simple ones that are perfect squares, no tricks, no gimmicks. And on all of these, you have just a 1x squared instead of a 4x squared or a 9x squared, which you could do, but we'll talk about that in later sections. Okay, the other that you're asked to know is your perfect square trinomial, which is a squared plus 2ab plus b squared. That is equal to a plus b quantity squared. On all of these examples, if you were to factor it using the x or some other technique, you end up with the same factor twice. So when you are trying to solve, you end up with just a single solution. Remember when we looked at number of solutions for a quadratic equation, and when we were looking at the parabolas, so the graphs of these quadratic equations, you can have two solutions, which means you have two x-intercepts. You could have one solution or one x-intercept, or you could have none. We're going to talk about the special cases when there's none later on in Unit 5. But for now, all of these on the left, these examples, we ended up with two solutions. Here in the middle, we end up with exactly one solution. So the pattern here is a little bit harder to see, but let's say I had something like x squared plus 6x plus 9 to start out. I notice that 6 and 9 are both multiples of 3. And so really the process, and we'll talk about this later also, if you take the square root of this 9 and you can double it, that means that this is a perfect square trinomial. And that's a little oversimplifying it, but especially in these examples, like I said, where a is 1, that's the pattern you're looking for. If you can take the square root and double that number and you get your b term, then that means that yes, this is a perfect square trinomial. So rather than having to factor it, you can just write it as x plus 3 quantity squared. And of course, if this was an equation, set that equal to 0, that means you have only one solution at x equals -3. Do another example, x squared minus 10x plus 25 equals 0. Take the square root, that's 5. If I double that, and remember your square root can be positive or negative, so this could be a -5. And if I double that, that's -10. That means this is x minus 5 quantity squared, which means you have a single solution at x equals 5. One more, x squared, let's do plus 26x plus 169 equal to 0. Take the square root, that number is 13. If I double it, that's 26. This is a perfect square. So this is x plus 13 quantity squared equals 0, which means you have a single solution at x equals -13. Again, I know I only did a few examples in this section, but it is a little bit of review from 4.1 and 4.2. And all the examples in your assignment this week are super simple, just like the ones that are here. So I think you guys should be okay on this one. But as always, if you need more help, please reach out to me. Have a good day, and I'll talk to you soon.